worksheet that I left you for the quiz tomorrow on exponent log word problems. You should be really prepared once we go through all these. Right, so let's take a look, see how you guys did. So this is our key. And the first question says, the Kwan family purchased their home in 2010 for $100,000. If the value of real estate increases at 10%, how much will the house be worth in 2025? All right, so you always start with what was the original amount? And the original amount was $100,000. So I'm going to write that down first. Then a parenthesis, then a 1. That never changes. Now you have to decide, is it increasing or decreasing? It says increasing. So 10% means we're going to add, because it's increasing, 10% would be 0.10. All right, now time. How much time has gone by? Well, in 2010, it was this much. I want to know what it is in 2025. How many years later is that? That is 15 years later. So that's now what I'm going to throw in my calculator. 100,000, make sure I have enough zeros, parenthesis, 1 plus 0.10 raised to the 15. And we're going to round to the nearest cent, so I'm going to put a dollar sign. It's 41774.82. So it's 6, right? That means that would round up to a 2. So if they don't tell you what to round to, and it's money, right? How much would the house be worth? You got to go to the nearest cent. So that's the answer for number 1. Okay, next one. On the day she was born, a girl's parents invested $2,000 in a savings account. Okay, at 6.25% interest compounded. How much will she have on her 18th birthday? All right, so we're starting with $2,000. Now, interest is money added on to an account, so we're going to put 1 plus. Now, let's talk about 6.25%. That's the same thing as 6.25%. Right? Now, when you had 10%, let's talk about this, right? That was 0.10, right? Because that means you moved the decimal point twice. So we're going to move this decimal point twice. So this will be 0.0625. So that's what I'm going to put here. Right? And we want to know 18 years later how much it's going to be worth. So 2,000, 1 plus 0.0625. Raised to the 18. And how much will she have? Okay, didn't tell us to round, so I'm going to do 5,955 and 95 cents. All right, number 3. A radioactive material has a half-life of 60 months. How much would a 100,000 gram sample be after 42 months? Okay, so we're starting with 1,000. Half-life means you're putting a half in the parenthesis. So if they say half-life, you put a half. If they say doubling time, you put 2. If they say tripling time, you put 3. Now, of is the same thing as an every. So that means it's going to be over 60, right? And that's in months. We want to know 42 months. That means 42 is going to go right there. All right, so I'm going to throw that in my calculator. 1,000, a half. Oops, I kind of messed up with the parentheses. Let's leave that out of it. Raised to the fraction, 42 over 60. All right. How much would they have after 42 months? 615.5722067 grams. If they don't tell you what to round to, you're not really supposed to round. I promise on your quiz I'm going to tell you what to round to, unless it's money. If it's money like these two, you have to assume near a cent. Okay? All right, let's get the next one. Jose owns a rare baseball card which increases in value by 15% per year. If the card was worth $350, how much? Okay, so the original price is $350. 1 plus 0.15. 2014, 2019, that's 5 years later. 3.50. 1 plus point, was it 15? And 5 years later. Now, it's money. And they didn't tell us what to round to, so we go to the nearest cent. $7.04 for that one. All right, 5. The populations of rats in a research lab is growing exponentially by doubling every, so it's doubling in every 9 months. If the lab started with 100, it's doubling every 9. That's how I'm going to set that up. What is the population after 4 years? Now, you're not going to put 4 in there, because what is the 9? What is the units? That's months. So we have to do, okay, 4 years times 12 months means we're actually plugging in 48 up here. So you got to make sure that these units match. Now, put my calculator, 100, 2 raised to the 48 over 9. Right? Now, the lab started with that many rats, so that's going to be 4,031.74736 rats. Okay. I'm going to ask you to round to the nearest rat, right? What would the nearest rat be if I said round to nearest rat? Right? If you did that, it'd be 4032, because the 7 would make him pop up. So if I ask these questions, I'm going to ask you to round to the nearest rat. All right, number 6. The population of triples. That means in the parentheses is going to be a 3. Initially there are 100. Okay. How many will there be every hour? So that means bottom is 1. 6 over 1. So we do 100. 3 raised to the 6 over 1 is just 6. And that's 72,900. All right, so that was the first page. If you notice, it's a lot of the same question over and over again. Okay. Number 7. The population of a small town is decreasing at a rate of 6%. Okay, decreasing. That's important. 6%. If the town's population was this in 2016, so the original amount is 12,250. 1 decreasing means we're going to put a minus. 6% is 0.06, right? And how many years have gone by? If the town's population was this, what is the population in 2011? Oh, I think that's a typo. What is the population in 2000? That's funny. Let's change this to 2021. That's a mistake. So we'll put a 5 in there. Okay. 1250, 1 minus 0.06, raised to the 5. Right? And that would be 890.324. Yeah, there was a silly typo which I didn't catch when I was looking at it. All right. So big things to take off of this. Decreasing means subtraction. That's important. All right. And I know already there's no typos on your quiz. I already did it, took the thing, and I'll tell you what to round to. So be very careful. Okay. The Richter scale number R, used to measure the magnitudes of earthquakes, is this equation. So I'm just going to rewrite the formula here. And this is a real equation for earthquakes. They do use logs. All right. Where I is the intensity of the earthquake, I sub 0 is the standard minimum response on the seismograph. The San Francisco earthquake of 1906 had a Richter scale number of 8.25. That means R is 8.25. Okay. And the registered response on the seismograph, that's I sub 0, is 177.8 million. Okay. How many microns are the... Okay, so this is going to be... We want to find I. All right. Well, how are we going to do this? What do you guys think? Well, if there's one log in the question, right, if there's one log, what we're going to do is bend it, right? The base, what's that base there if you don't see a number? I'm hoping you're thinking, hey, that's right, it's 10. So this becomes 10 to the 8.25 equals I over 177.8. Okay. So I'm going to go to my calculator. It's 10 raised to the 8.25. And we're going to multiply that, right? I'm going to put this over 1. Cross multiply. Times 177.8. And you got 3.2 times 10 to the 10. That's how you would set that up. I'm not going to have one like this on your quiz. I just wanted you to see how you can use logs for earthquakes. I thought that was kind of cool. So I'll put a little star next to this one because that's nowhere near as hard as anything you guys would have to do on your quiz. I just thought it was a cool question. All right, next one. The relationship between the elevation h in the miles above sea level and the atmospheric pressure P is given by this equation. P equals 29.92 e to the negative h over 5, also known as Halley's law. Using this equation, determine the pressure at the top of K2, the second highest mountain in the world, at 5.35 miles above sea level. All right, and remember h is miles above sea level, so that means we're plugging that in for h. So I'm doing 29.92 e negative 5.35 over 5. So this is basically just a calculator question. 29.92. The E button, right? It's right next to the 4 second. You got E. Throw in a fraction. Negative 5.35 over 5. All right, and this would be 10.26281484. And again, I'm probably going to have you round usually either to the nearest 10th or the nearest 100th, right? What would nearest 10th be if I asked you to round to that? That would be 10.3. Okay. Next one, number 10. The half-life, half-life means you throw a half inside the parenthesis, is 10.3 days. So that's what's going to be in the bottom of our fraction. If the original amount was 290, the original amount always goes in front of the parenthesis. How long will it take? Ooh, this time I have a T up there. How long is time? I don't know. I have 40 left over. All right, you got to solve this guy. So the first thing you're going to do is divide by 290. Never multiply 290 times the half. You always divide it off. So get rid of him. And I'm going to bring it up here. That leaves me with 1/2 to the t over 10.3 equals, I'm going to do 40 divided by 290. I'm going to write down the whole decimal. I'm only going to round at the very end. Okay. So now I've got to figure this out. Now, the thing we're missing is in the exponent, so we're going to have to use a log here. So I'm going to do log 1/2 of all of that equals t over 10.3. All right, so I'm going to go to my calculator. Now, I'm going to leave that number on the screen. I'm going to hit math, go up to log, put in 1/2. I'm going to put in 0.5. Then, for this guy, I'm just going up and grab him. See, and it puts it in there for me. And we have this guy. So it's 2.857980995 equals t over 10.3. So make him look like a fraction. Cross multiply. So I'm going to do that guy times 10.3. Right? Does it tell us what to round to? Let's go to the nearest tenth. And I'm going to say 29.4. All right, and finally, okay, the number of ants in an ant farm is represented by this formula. What is everything we know about the ants? All right, well, the number in front is how much we're starting with. So starting with 235 ants. Or you can say the original amount of ants is 235. Now, the next thing, is this thing increasing or decreasing? It is increasing because 1.23 is bigger than 1. So, if the number in the parenthesis is bigger than 1, it's increasing. If the number in the parenthesis is smaller than 1, it's decreasing. Now, what percent is it increasing by? Well, if you subtract 1 from the number in there, you get 0.23, and that means it's increasing by 23%. So that's everything we know from that equation. Real quick, let's say H equals, I don't know, 972.21 to the T. And I said that equation represents the number of horses out to pasture. What is everything we know about the horses? Well, I'm hoping you're thinking the original number of horses. Right? What would be the original number of horses? 972. So that means we're starting off at 972. You also need to be able to tell me if this function is getting bigger or smaller. Is it increasing or is it decreasing? And how do you know? This one is decreasing because 0.21 is smaller than 1. Okay? Now, we need to know what percent it's going down by. And it is not 21%. Remember in the last one, to find the percent, I had to subtract from 1. So that's the same deal. You're always going to do whatever number is bigger. In this situation, 1 is bigger. I'm going to write that first. 1 minus 0.21. So I'm going to do 1 minus 0.21, getting 0.79. That's the percent. So it's going down by 79%. That's how much it's decreasing by. All right, guys, you should be super prepared now for your quiz. It's going to be not this long. I had to practice almost the same skill over and over and over again. I think it's 6 questions, but some of them have part A, part B. I tell you what to round to, unless it's money. Money, unless I tell you otherwise, you always round to the nearest cent. And, oh, real quick, anytime you see anything like this, right, that symbol means it's an exponent. Sometimes with the computer programs, I can't make it look like an exponent. So anytime you see this, it means it should be a squared. Also, if I give you like 200, let's say it's 2, and then you see this, and it's t over 8, like that. That means it's 202 t over 8. And that should have if you have to type this into a line, that's how you should do it. All right, guys, you should be all set. Good luck on the quiz tomorrow.